5C says, write but do not evaluate the integral expression that gives the volume of solid when R is rotated about the horizontal line y equals 2. So y equals 6. So 1, 2, 3, 4, 5, 6. Y equals 6 is going to be this line here. So when we rotate this volume around there, we're going to end up with this shape generating, it will generate washers. Okay, so we need to do volumes of rotations, and the volume is using washers. Okay, so if we're going to use washers for this, we need to find the area of the washer, and the area of the washer is going to be pi of the big R squared minus pi of the smaller circle. So we take the big circle and we subtract the smaller circle and we get a washer. So when we take the volume of this function, the volume of this solid, we're going to rotate this solid and we're going to integrate it from 0 to 2, and we're going to take the area of the washer and we're going to give it some thickness, dx. Okay, again, area times thickness is going to give us volume. So we can simplify this a little bit. We can factor out that pi, and then we can write this function in terms of the radius of the big circle. Okay, so when we think of the radius of the big circle, maybe I'll do this in a different color here. The radius of the big circle, if I rotate this expression, I'm going to get this big circle. So the radius of that big circle is going to be the distance from this line to this line here. Okay, and that is going to be our big radius, which is equal to 6 minus the bottom function, which is the cosine function, or g of x. If I want to then find the radius of this smaller circle, that the smaller washer, is going to be this distance here. Okay, we'll call that small r, and that's going to be 6 minus our h of x function. So those are going to be the expressions that represent our radius. Then we can put this into our expression here, the big R squared. Do this in a different color here. The big R is going to be 6 minus g of x. Make sure that looks like a 6. Okay, so we end up with 6 minus g of x squared. And then we're going to subtract the smaller radius, which is going to be 6 minus h of x. That will give us the washer shape. Square that radius. That's the area of our washers. We give that area some thickness, and we calculate the volume using that integral.